Hello students, welcome to the Avanti classes. Let's discuss the PYQ on chemical kinetics. So I think you have gone through all the previous videos or whatever we have covered in the last three videos. So at last three videos, we have covered all the theory of the chemical kinetics and we have also solved the plenty of problems. So in this video, we are going to discuss, or in this lecture, we are going to discuss some previous year questions on chemical kinetics, which is come in the whatever it come in the JE and NEET. Okay, so let's start our class. Once again, good afternoon, all of you. Welcome to the Avanti classes. Okay, here we are going to discuss the some PYQ on the chemical kinetics. So here is the first question. In this question, the reaction is given. Okay, for the given first order reaction, so they have mentioned that this is the first order reaction earlier. Okay, so this is first order reaction. So the reaction is reactant A, which gives the product B. The half-life of the reaction is given 0.3010 minutes, and the ratio of initial concentration of reactant to the concentration of reactant at the time 2 minutes will be equal to. So this is very simple question. They have given the half-life, and they have to find out. We have to find out the ratio of initial concentration of the reactant and the concentration left at 2 minutes. Okay, when reaction proceeds, it will move towards the 2 minutes, and we have to calculate the ratio of concentration of reactant and initial concentration of reactant and the concentration at a time 2 minutes. So let's discuss this. So let's try. So I know that, okay, so given it's T half. Given is T half, but this first important given is first order reaction. So this is first order reaction, which has T half. Okay, T half 0.3010 minute. So this is our T half. So I have to find out the K, which is raised constant. So K is equal to what is the value? 0.693, 0.3010. So this is formula for finding out the K through the first order reaction. So value of K will be equal to 2.303. So this is value of K, which is our rate constant. So we know that integrated rate equation for the first order reaction. What is that? So can anyone tell me what is the integrated rate equation? Yeah. So yeah, very good, very good. So what is the integrated rate equation? K is equal to 2.303 upon time in minute, second, whatever it may be, into log A naught upon A. So what is A naught? A naught is the initial concentration, and what is A? Concentration at time t. So here I can say A. So we have a K value, we have a T value, and we have to calculate the ratio of this term. So we can calculate it very easily. So let's put all the values and solve the question. So K values, I know the K value 2.303 is equal to 2.303 upon what is the time? 2 minutes. Log A naught, which is initial concentration, upon concentration at time t. So this is our equation for solving out the problem. So we can cancel out the terms here. We can cancel out 2.303 cancel out, 2.303 cancel out. So 2 is equal to log A naught upon AT. So simple funda. So here we can add, okay, putting anti-log on both sides, putting anti-log on both sides, anti-log. So here you can say 10 to the power 2 is equal to A naught upon AT. So what is the ratio between A naught and AT at time 2 is 10 to the power 2. That means I can say it A naught, ratio of A naught to AT is equal to 100. So this is our final answer. So ratio of A naught to AT is equal to 100. So I think it's clear to all of you. What is the problem? What is its answer? Simple question. We have to just think about the what is the first order reaction, and we have to calculate the K. So I think it's clear to all of you. I'm moving forward to the next question. Question number 2, which is come in the NEET 2021. The question says that the slope of Arrhenius plot, which is natural log of K versus 1 upon T. Yesterday we have discussed that. So for a first order reaction is minus 5 to 10 to the power 3 Kelvin. So this is value of slope. Okay, so they have mentioned a slope. So the value of EA of the reactions. So we have to calculate the activation net. Okay, it's very, very good question. Okay, think about the question and please, okay, try to solve it and we'll discuss later. So you have 1 minute time and I will discuss it later. Okay. So think about it. Yesterday we have discussed what is the graph between natural log of k versus 1 of t, 1 by t. So you can calculate very easily. Okay, so whatever the slope value they have given, and we know that how to calculate this. Okay. Okay, I'm getting responses in the chat box. Very good, guys. Very good. So yeah, okay. Yeah. So I think I got many of responses in the chat box. Let's discuss the question. Right? Let's discuss the question. So the question says that what does question says that we have a slope value for a plot natural log of k versus 1 half t, 1 by t, not 1 half t, 1 by t. So I know the RNS equation. Okay, I know the RNS equation, that is k is equal to a into e to the power minus ea upon rt. So this is my RNS equation. If I apply natural log of k on both sides of the equation, so what is the equation then? Natural log of k is equal to natural log of a minus ea upon rt. So if I split it, natural log of k is equal to minus ea upon r into 1 by t plus natural log of a. So it looks like the equation mathematical equation. So this is k versus 1 by t. Here there is a y intercept which is value is equal to natural log of a. So this is our the plot. So here slope will be the minus ea bar r. So what is the value of slope here? So they have given the slope value is minus 5 into 10 to the power 3. So I got a value of ea by r is minus ea by r is equal to minus 5 into 10 to the power 3 Kelvin. So this is the value of slope. So here I can say, so ea by r is equal to 5 into 10 to the power 3 Kelvin. So this will be our equation. So from that I can find out the value of ea, that is activation energy. So I know that r value is equal to 8.314. So put the value and get the answer. ea is equal to 5 into 8.314 into 10 to the power 3. So what is the final answer then? It will have values 41.5 kilojoule per mole unit. So this is activation energy we have to calculate. Okay, so very simple question. You can calculate very easily. I think it's clear to all of you. So please reply in the chat box or say yes or no in the chat box. Is this clear or not? Then we will proceed to the next question. So before going to the next question, let's circle the answer, proper answer. Option A is the correct answer. Which is answer correct? Option A is the correct answer. So option A is the correct answer here. So I think all the people have tell the correct answer. So let's move forward to the third question. Okay. Third question is that if the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by. So what they have told us that rate constant for first order reaction is K, and the time required for the completion of 99% of the reaction is given. So very, very good question. NEET 2019 question. So you can solve it very easily. Okay. You can solve it very easily. Tell me the answer in the chat box. Okay, take your time to solve the question and tell me the answer in the chat box. So you have 1 minute time. Try to solve the question. This is first order reaction, and we have to calculate the T for 99% of the reaction. Okay, 99% completion of the reaction. So very good question. You can solve it very easily. Think about the first order reaction and its half-life. You can tell me the answer. Okay, So let's try to solve the question. Okay. So what they have given, they have told us that this is a first order reaction. Which order reaction? This is a first order reaction. So for first order reaction, we know that K is equal to 0.693 T half. So this is my for first order reaction. Okay. So this is for first order reaction. Just a minute. Okay. So T 1/2. Okay. So this is for a first order reaction. So I can say T 1/2 is equal to 0.693 K, or I can values put at the like this. No issue. I can put the value like this. So for the 99% completion, okay. So if I take the reaction, A naught should be the 100 and 80 should be the 1, because the reaction is completing in the 99%. So if I solve it, so 80 is equal to 1. So I know the integrated rate of first order reaction. As I have told you, all the 50% problems will come from the first order reaction. So you have to remember the integrated rate equation for a first order. So what is the first order integrated rate equation? K is equal to 2.303 upon T is equal to log A naught upon 80. So this is my integrated rate equation. You know the values, you know the K values. From here you can see the K values. You have to find out the T, and you know the A naught values, you know the AT values. So you can put all the values in the equation. So K is equal to 0.693 upon T half. Okay. So here I can calculate. So T is equal to, okay. So here I can see that T half value is given to us. Okay. So here I have to put the value of T half. So I can put the value of T half. So it will give the value of K in the terms of K only. No need to put the value of T half. So we have to find out the only the in terms of K. So I'm not putting the value of K. We just need the value in the terms of K only. So I'm not putting this value. So let's erase it and let's pull the other formula, other values. That is K is equal to, it's not erasing. Okay. So K is equal to 0.693 upon T log of A naught K value 100 upon 80 value 1. So if I solve it, K is equal to 0.693 upon T is equal to log 10 to the power 2. So what is the value of that? No, 0.6 not, sorry. So this should not be 0.6. It should be a 2.303. Okay, this is 2.303. So I know if I have a log 10 to the power 2, so it will the K is equal to 2.303 into 2 upon T log 10. So K is equal to 4.606 upon T log 10 is equal to 1. So time required for this is equal to 4.606 upon K. So this is our answer. T is equal to 4.606 upon K. I think it's clear to all of you. Is this clear? Guys, tell me the answer. Is this clear? You get the answer. Is this clear? So think about the problems, think about the answer, go to the answer. I think it's simple. Okay, you can solve it very easily. So I have the option A, B, C, D. Which is the correct one? Option B is the correct. In this, all the questions, option B is correct. So these are the simple questions. You can solve it very easily. So moving forward to the next question, question number 3. This is also JEE Mains 2022. And this year, okay, this year they have asked the question JEE Mains 2022. So reactant A gives product B. If a formation of compound V follows the first order kinetics, means this reaction is a first order reaction. And after 70 minutes, concentration of A is found to be half of its initial concentration. So basically, they have given the T half. Okay, 70 minutes means T half. So then the rate constant of the reaction is. So we have to calculate the rate concentration. Very simple question. You have to put the values and get the answer like that. So these questions are asked in the JEE Mains 2022. So you can solve this question very easily. So think about the question and tell me the answer in the chat box. Sorry, tell me answer in the chat box, guys. Very simple question. You can solve it very easily. You have formula K is equal to 0.693 upon T half for first order reaction. So this is your question. So this is our formula for this question. So tell me the answer, proper answer. I will wait for 1 minute and you have to solve the question and tell me the answer. What is the answer, guys? Tell me. Okay, so I'm going to discuss this. So what they have saying that first initial state is this is first order reaction. Okay, first order kinetics. It follows the first order kinetics. That means it is a first order reaction. And we know that for first order reaction, they have given the half life. So T half for this reaction is something 70 minutes. Okay, 70 minutes. And we have to calculate the rate constant, which is equal to K. Okay, so I know that for a first order reaction, what is the relation between T half and K? Is the rate constant. I know that K is equal to 0.693 upon T half. So this is our equation for finding out the rate constant of the reaction. So, but here I have to find it out the rate constant in the second inverse. So this is very important. In questions, they have asked in the second inverse, but our time is given in the 70 minutes. So I have to convert it in the seconds. So 70 into 60. So this will be the time in the whatever it will be 4200 seconds. Okay. So if I put the value of T half in this equation, I will get K is equal to 0.693 upon 70 into 60 second inverse. So what is the value of K? It should be the 0.693 upon 4200. Okay, this is the value of K, which is in the second inverse. Okay, so K is equal to 0.000165 second inverse. So this is value of K. If you calculate it, you will get this value. So I can say that K is equal to 165 into 10 to the power minus 6 second inverse. So they have to find out the value of this term, which is the X. So what is X value? X value you can calculate. So what is X value here? X value is the 165. X is equal to 165. So what is the final answer then? You can write it down 165. Okay, so 165 is the final answer for this question. Simple question, easy question. You can calculate the things very easy. Okay, so moving forward to the next question. Okay, so in this question, for the following graphs, choose the from the option given below the correct one regarding order of the reaction. So we have to calculate graph and you have to see the which is correct option. So we know that for a zero order reaction, what is the graph, what is the relation between rate constant and time, what is the relation between concentration and time, and what is the relation between rate and concentration. So this is for a zero order reaction. Okay, so tell me the answer then. So think about the question. This is also JEE Mains 2022 15 July. Okay, so you can tell me the answer in the chat box. So think about the question and tell me the answer in the chat box. YouTube guys, you can also give the answer in the chat box and tell me the answer in the chat box. So think about the question. Very good question. For a zero order reaction. So very important, guys. You can tell me the answer. Correct one regarding the order of the reaction. So here option B is the option C is the correct one. Why? If you see the option E is for the first order reaction. Yeah. rate of the reaction is directly proportional to the A, that is initial concentration of the reactant as a power 1. So if I increase the initial concentration, the rate of the reaction will increase. So this is E for the first order reaction. I think no doubt. If I see the D graph, what is D graph? Concentration and time. So for zero order reaction, the concentration and time graph is almost a straight line which is parallel to the x-axis. And option B, T half. We know that for T half, okay, so it is directly proportional to the A in the zero order reaction. For zero order reaction. So this is a T half which is directly proportional to the A. So option C is the correct one in this question. So I think it's clear to all of you. So you have to see the option A, B, C, D, E. There are the graphs, sorry, these are the graphs. You have to choose the correct answer, which is option C. Okay, so this is for the chemical reaction. Moving forward, this is very good question. The rate constant of K of the reaction is measured at different temperatures T. Okay, so the data are plotted in the given activation energy of the reaction in kilojoule mole inverse. So this is graph between natural log of K versus 1 by T. So you can tell me the answer. You have to find out the slope and you can tell me the value of E. That is activation energy. So how can you find out the slope? So tell me the answer. Think about the question and tell me the answer in the chat box. What will the answer? Gas constant and activation energy. Guys, tell me the answer in the chat box. Very simple. What we have told you. Okay, think about the RNA's equation and you get the value. So if I want to find out the slope, okay, so if I want to find out the slope from this point, so I will take this as a 6 and this point as a 4. Okay, and I will calculate the slope from this equation. Okay, so what will the slope value? Y2 minus y1 upon x2 minus x1. This will be our slope. What is y2? Y2 value is 4 minus y1 6. What is x2 value? 3 minus x1 2. So this is x1, this is x2, this is y2, this is y. So what is the slope then? I will get the slope value minus 2. So I have to calculate the slope. What is the need of calculating the slope? I know that RNA's equation. What is RNA's equation? In RNA's equation, K is equal to A to the A into E to the power minus A upon RT, where EA is the activation energy, R is the gas constant, which is 8.314, and T is the temperature of that reaction. So if I apply again natural log of, so natural log of K is equal to natural log of A minus EA by RT. Okay, and if I shuffle a little bit this equation, natural log of K is equal to minus EA by RT plus natural log of A. So this is our equation. So if I solve, or I can say y is equal to, this is my m. Okay, and if I little bit wrote 1 by t here, so 1 by t is my x plus c. So natural log of A is my activation energy. Okay, so natural log of K is my, sorry, natural log of A is my activation energy, and I can calculate here very easy. So you can put the values and tell me the answer here. So how can you calculate this? The slope, which is m. Okay, so m value should be is equal to minus EA by R. So what is this? It is our slope. Okay, so if I calculate furtherly, I know the slope value. Slope I calculated, I have calculated the slope value. Slope value is equal to minus 2, which is equal to minus EA by R. So yeah, EA is equal to, what is the value then? 2 into R. So what is the value of R then? 2 into 8.314. Okay, so this is value of R. So what is the value of activation energy? It should be the 16.628 joules. So this is the value of activation energy. So what is in the, this is in the joules, but how can I have to calculate? I have to calculate it in the kilojoules. So it will the 0.016 into 10 to, sorry, is 0.06 kilojoule per kilojoule per mole. This is my activation. Okay, so this is my activation energy in terms of kilojoule. So this is one way you can find it out the slopes, but again you can find it out the another one. So you got the natural log of a value, है ना? So here you can say, so here if you write it down any perpendicular on this uh, slope, sorry, on this curve or on this line, you will get here the some point called 2.5. So if you take a 2.5 as a temperature, 2.5 Kelvin, so here you can calculate the activation energy. Okay, so here also you can calculate the things, but most reliable thing is that if you have to find out the slope of the reaction. So I think it's clear to all of you. Moving to the next question. Is this clear, guys? JNV Mahe, is this clear? So moving forward, the next question. Next question is asking us if 60% of the first minutes and 50% of the same reaction would be completed approximately in. So they have given that first order reaction. Initially, what they have said, first order reaction, which is completed in the 60 minutes, and the completion of the reaction is the 60%. Okay, so 40% reactant is left unreacted, okay, at 60 minutes. So we have to find out the 50% of the same reaction be completed in approximately. So 50% means kya? So 50% means half of the reactant is left unreacted, okay, or I can say it is a half-life period. So we have to calculate the half-life of the this reaction. So very good question. You can solve it very easily. Tell me the answer in the chat box. Okay, solve this question and tell me the answer in the chat box. Very simple question, guys. You can solve it very easily. Tell me the answer in a chat box. Very simple, very simple. Okay, so let's discuss it. Discuss the question. Okay, so what the initial things are given. First, very important thing is first order reaction. First order reaction. And another important thing is 60 minutes for 60% completion. 60% completion. Okay, so this is our initial things they have given us. Okay, so I know that for first order reaction, okay, for first order reaction, K is equal to 2.303 upon T is equal to log A naught upon A T. Okay, so this is the for first order reaction. So how can I calculate this up? So I know that 60% reaction means A naught is 100. So at 60 minutes, 60% reaction is completed. So A T at 60 minutes should be the 100 minus 60. That is a reactant which left over. So I know the 80 K is equal to 2.303 upon 60 into log 100 upon 40. है ना? Log 100 upon 40. So K is equal to 2.303 60 into log. This will cancel out 10 upon 4. So K is equal to 2.303 upon 60 into log 10 minus log 4. Okay, so K is equal to 2.303 upon 60 is equal to log 10 I know 1 minus 0.6, which is the value of log 4. So if I calculate it, k is equal to 2.303 upon 60 into 0.4. So k value will be the value of k will be the 0.0153. So this is value of k. So I have pre-calculated this value. So need not to be worried about it. So I got the k value. For t half, I know. For t half, I know 0.693 upon 0.0153. So this is t half. So t half is equal to 45.29 minutes. So this is our t half. Okay. So this is our t half for this reaction. So I think it's clear to all of you. Okay. Say yes or no in the chat box if it's clear to you. Okay. We'll move forward. So tell me in the chat box, sir, it is clear to all of you. And we'll move. Okay. Move next. So what is the final answer then? The answer is 45. The nearest answer is 45 minutes. So option B is the okay. Option B is the correct one. 45.29. So option B is the correct. So moving forward to the next question. The next question is CBSE AIPM 2006. This is also a very good question. Not that much very hard, but very simple. You can tell me the answer in a fraction of a second. For a reaction, twice A plus B gives 3C plus D. So this is a simple chemical reaction. Twice A plus B, which gives thrice C plus D. So which of the following does not express the reaction rate? So you have option A minus DC upon 3D T. Option B minus dB upon dt. Option C dt upon dt, and option D minus dA upon 2 dt. So these are the options in front of you. So think about the question. Very simple question. You can tell me the answer in within a fraction of. Yeah, very good, man. So very good, my guys. Okay, so that is correct answer. Okay, so let's discuss which is the correct answer. So I know that. Okay, I know that for this reaction, if I find out the rate, I know reactant concentration is decreasing. Okay, reactant concentration always decreasing because reaction is proceed forward, and product concentration is always increasing. Okay, product concentration is always increases. So for reaction, what is the reaction? Twice A plus B gives twice C plus D. So twice A plus B gives thrice C plus D. So this is our reaction. Okay. So for this, according to this rule, reactant concentration is decreasing and product concentration is decreasing. So I can calculate its rates as a minus dA by A upon dt, which is divided by 2, is equal to minus dB upon dt is equal to 1 upon 3 dC by dt is equal to dd by dt. So this is our equation in front of us. So what we have to calculate? We have to see, not calculate, we have to see the correct option. So option A itself is the wrong. So option A is the correct here. It does not express the reaction rate. This is expressing the reaction rate. This is also expressing the reaction rate, and this also expressing the reaction. So option E is not expressing the reaction rate. So our correct answer is option A, which is wrong in the terms of reaction rate. So I think it's clear to all of you. Moving forward to the next question. Very good question. Again, for the reaction, twice N2O5 gives 4NO2 and O2. So this is simple reaction, simple way. So rate of and the rate constant R. So this is the rate of reaction. 1.02 into 10 to the power minus 4 and rate constant 3.4 into 10 to the power minus 5. Second inverse. So this is very important. We have to see the what is the unit of rate constant. So these are the values given respectively. The concentration of L2O2 at the time will be. So they are asking about the initial concentration, basically. So I have circled this second inverse. So can anyone tell me if the reaction, okay, the unit of rate constant is second inverse, then what is the order of reaction? Can anyone tell me? If unit of the rate constant of the reaction is the second inverse, then what will the order of the reaction? Can anyone tell me in the chat box? Very easy, very easy. Second inverse. Which order reaction has a rate in the second inverse? Which order? Yeah, very good, Jen. The first order reaction is the our rate constant, which has a unit second inverse. So this is for a first order reaction. First order reaction. So solve this and tell me the answer. What is the answer? What is the final answer? JNV Mahesh students, can you tell me the answer? What is the correct answer here? Solve the question very easily. You have given the rate of the reaction at rate constant. You can calculate the concentration of the N2O5. And for your information, this is a first order reaction. Please don't forget that. This is a first order reaction. Don't forget the things. Okay. So tell me the answer, Jenny Maya. Okay, so let's discuss it. Okay, let's discuss. Okay, so I have a rate of reaction. I have a rate of reaction. What is the rate of reaction value? So 1.02 into 10 to the power minus 4. So this is the rate of reaction. What is K value? K value is 3.4 into 10 to the power minus 5. Okay, this is second inverse. So if I say this is first order reaction, so I can write rate is equal to, which is rate of reaction is equal to K into, okay, N2O5 1, because this is a first order reaction. So I know that, okay, the first order reaction has a unit second inverse. So what is the rate? Okay, rate of the reaction 1.02 into 10 to the power minus 4. What is the rate constant? 3.4 into 10 to the power minus 5. Okay, so if I calculate it into N2O5, so I have to write it down N2O5, which is concentration of N2O5. So the concentration of N2O5 is equal to 1.02 into 10 to the power minus 4 upon 3.4 into 10 to the power minus 5. So this is our final answer. Three into 10 to the just simply 3. So it will the molar. So basically we are enough. So this is the option. Which option is correct one? Option A is 1.732, which is wrong. Option B is correct one. So option B is correct one, which has the option B, which is equal to the 3. So I think it's clear to all of you. Simple question, simple answer. Is this clear, guys? Krishna, JD, my students, is this clear? Should I proceed to the next problem? Okay. So I'm proceeding to the next problem. Chalo. So question very important. Okay, question number 10 of this PYQ discussion. So the correct difference between first and second order reaction is that option A, first order reaction can be catalyzed and second order reaction cannot be catalyzed. Okay, this is option A. Option B, the half-life of first order reaction does not depend on the A naught, and the half-life of the second order reaction does depend on the or does depending on the A naught. So the rate of first order reaction does not depending upon the reactant concentration. This is wrong statement also. The rate of the second order reaction does depending on the reactant concentration. This is correct one, but this is the wrong statement. So option C statement is wrong. And option D, the rate of first order reaction does depend on the rate concentration, reactant concentration, and the second order reaction does not depending. So this is also a wrong statement. So statement C and statement D are wrong. So you have to distinguish between option A and option B. So I have completed your 50% work. So tell me the answer. Very good, genuine students. So let's discuss the answer. Krishna. Okay, so let's discuss the answer. What is the correct answer? So I know that for a first order reaction, initial half-life of this reaction is equal to 0.693 upon K. So in this, okay, half-life of this reaction, we cannot see any concentration term. You know, concentration terms is not there. So the half-life of this reaction is not depending upon the concentration, initial concentration of the reactant. But if I see the T half for the second order reaction, this is for the first order reaction, first order. And if I see the T half, I will get, okay, so I will get some value 2K A naught, like that. I will get the value 2K A naught. So it may be T half, which is directly proportional to the A naught n minus 1. So this is the value. Okay. So here for a second order reaction, the T half is depending upon the A naught, whatever it may be, inversely proportional or directly proportional. But at the end of the day, it is depending upon the concentration of A naught. So what is the answer then? In first order reaction, A naught. Okay. So half-life is not depending upon the A naught. But in second order reaction, the half-life is depending upon the A naught, and which is inversely proportional to the A naught. So option B is the correct one. So I think it's clear to all of you. Option B is the correct. So I'm moving forward to the next question. Moving forward to the next question. So very good graph. Yeah, I can say very interesting question is there. So consider the reaction. We have 4 reaction. Reactant A gives product P1, reactant B gives product P2, reaction C gives product P3, and reaction D gives product P4. So these are the 4 reactions. The order of the above reaction are A, B, C, D. So whatever order they have not given the numerical value, that's first order, second order. They just say that order of the reaction are A, B, C, D respectively. So for first reaction, order is A. For second, B. For third, C. And for fourth, D. So these are the order of the reaction. The following graph is observed to fail. Log, which is rate of the reaction, log rate versus log concentration are plotted. Okay. So we have to say about the among the following the correct system for the order of the reaction. So which has more order. Okay. So which has more order. So order A is more than order B, order B is more than order C, and order C is more than order D. So very important question and very good question. Okay, so it will clarify all the things in the chemical kinetics, the initial things of the chemical kinetics. So tell me the answer of this question. Think about the question and tell me the answer of this question. Think about the question and tell me the answer of this question. Okay, so let's discuss this question. I know that, okay, I know that rate of the reaction is equal to K into what is a reactant concentration, or if I take it as A, so K into, so K to the power N. If first order is there, is equal to N is equal to 1, second order is there, N is equal to 2, third order there, N is equal to 3. So these are the things. So if I put a logarithm on the both side, so I will get log rate of the reaction is equal to log K plus log A to the power N. So I know that log rate is equal to log K plus N log A. So this is the reaction and this is the equation. So I can say this is my Y. Okay, this is my M, this is my X, and this is my C. So this is my Y. So I can put it as a Y is equal to MX plus C. So here my slope is equal to M, and which is equal to N. So N is nothing but the order of the reaction. So order of reaction. So I can say slope value is nothing but the order of the reaction. So highest the slope, I can say here, more the slope, more is the order, more the slope, more the order. Higher the slope, higher the order. So from this equation or from this relation, I have to find out the which has the more slope. So by seeing the things, you can say that D has the more slope than B. Okay, and B has the more slope than A, and A has the more slope than C. So which is correct option then? D, B, A, C. So option A is the correct. So because the D reaction or the D reactant which has the more slope than the B, than the A, and than the C. So I know the relation between slope and order of the reaction. More will the slope, more will the order of the reaction. So is this clear, Jenny, my students? Simple question. I think it's very simple. You can solve it very easy. So is this clear, guys? Okay. So let's discuss 2-3 more problems and we'll end here. So this is very simple one. Moving forward, very good question again. JEE Mains 2020. So yeah, 2020. The flow contains mixture of compounds A and B. So this is the flux constant mixture of compounds A and B. Both compounds decompose by first order kinetics. The decomposition going through the first order kinetics. The half-life of A are 300 seconds and half-life of B are 180 seconds respectively. If the concentration of A and B are equal, okay, initial the concentration of A and B are equal, initially the time required for the concentration of A to be 4 times than that of B. So we have to calculate the time required. That is time where the concentration of AT should be 4 times concentration of BT. So we have to calculate this. So very important question. Very good question. You can calculate very easy. The time required where concentration of AT is equal to concentration of BT. So tell me the answer, correct answer in the chat box. Think about the question. Don't be in a hurry. Very easy questions. Just use small tricks in your mind and tell me the answer. Okay, so I'm going to solve it here. So A has half-life. Okay, A has half-life 300 seconds. So here initially A and here B. So here initially 100. Okay, 100 constant 100 molar. Okay, 100 molar we are taking. So after 30 seconds, it will have a 50 concentration, 50 molar. Again, after 300 seconds, it will have concentration. I'll just write it very clearly. 25. Okay, and again 300, it will have a concentration 12.5. Okay, so these are the 3 things. Here I have to find it out that AT, okay, the concentration at time T of A should be 4 times the concentration of B at time T. So the T should be the constant for both. So time should be, we have to calculate. So it will convert into the 50 in 180 seconds. It will convert into the 25 in 180 seconds. It will convert into the 12.5 in 180 seconds. It will convert into the 6.25 in 180 seconds. And it will convert into the, I can say 3.125 in 180 seconds. So I know that 12.5 divided by 4 is equal to 3.125. So this is a concentration of A and this is concentration of B. So for this concentration, what is the time required here? So 300, 300, 300, total 900 seconds. And here, how many? 180, 180, 180, 180, and 180, which is the also 900 seconds. So time is same, 900 seconds, but here the concentration of AT at 900 seconds is 4 times concentration of B at 900 seconds. So which is the correct answer? Answer D is the correct one. Option D is the correct one. So easily you can find it out the things in the this one. Okay. So I think it's clear to all of you. Moving forward to the next question, JEE Mains 2019. Okay, the question says that, okay, the reaction 2x gives B is a zeroth order reaction if the initial concentration of X is 0.2 molar and half-life is the 6 hours. When the initial concentration of the reaction is 0.5 molar, then the time required for a reach its final concentration of 0.2 molar will be there. So they have given the initial concentration, okay, for a zeroth order reaction. Okay, the half-life is the 6 hours. So I can calculate the K value easily. Okay, so think about the question and tell me the answer in the chat box. Very simple question. You can tell answer in the easy way. Okay, let's try to solve it. I know what is given, very important. This is zeroth order reaction. Zeroth order reaction. So what is this? This is a zeroth order reaction. For this reaction, for this reaction, I know, okay, I know T half is equal to A naught by Y scale. So this is T half is equal to A naught by Y scale. So A naught is equal to 0.2. Okay, so here they have given A naught value 0.2 and K value, sorry, T half value is 6 hours. Okay, so I can find out the K value. So K is equal to A naught divided by 2 into T half. So here I can say 0.2 divided by 2 into 6. This is K value. So K is equal to 0.2 upon 12. So I can say K is equal to 1 by 60. So this is value of K. So for first order reaction, I know that concentration at time T is equal to A naught minus KT. This is for a, sorry, this is for a zeroth order reaction, not first order. This is for a zeroth order reaction. So I know the, I have to calculate the 0.2. Okay, this is 0.2. I know the 0.2. It has to reach the 0.2 concentration, 0.2 molar. Okay, so I have to find out the time, and initial concentration is given as 0.5. So here I can calculate 0.5 minus K value 1 by 60 into T. So it is equal to 1 by 60 into T is equal to 0.3. So T is equal to 0.3 into 16. So it will be the 18. So what is the correct answer? T is equal to, sorry, T is equal to 18 hours. Okay, so this is our correct answer. So T is equal to 18 hours. So option A is the correct one. So what is the correct answer here? Option A is the correct. So T is equal to 18 hours. So I think it's clear to all of you. So that's for today, guys. We have solved the plenty of problems. Okay. So thank you for your cooperation. Thank you. Thank you very much. We'll see you in the next weekend again for the enable classes. Thank you. Bye-bye.